Hi, the purpose of today's update is just to set our game up with some 3D projection. So this is what we've got. We've got 4 walls, and as we walk around, we can see stuff. Okay, so this is what we're leading into. Let's have a quick look at the concept behind it. Okay, so imagine we have a wall, and the wall is in view coordinates, which means it's centered around the camera. The goal is to take that and work out the positions on the screen that we would need to draw it. Now, this perspective is based on vanishing point, which means as this wall gets further away from the camera, it should kind of converge towards the center of the screen. So we've got these points A and B. Here's how we're going to do it really quickly. We track, how far to the left point A is, its x coordinate. We track how far to the right point B is, its x coordinate, and we put that on the screen, centered around the origin of the screen. And then if we divide by the depth or the distance from the camera, that will kind of scale it. And the way I'm doing it in this one is I'm using the difference in y coordinates to set the distance of each pixel or each point from the camera. And then we'll just use the wall's z height to set its y coordinates and divide. So for each point we have like an x offset and a z offset, and that's set by the coordinates of the wall. Cool, so let's have a look at the code again. Okay, to start with, we'll just have a look at one method which kind of works but not quite, and then we'll look at the improved method. I'm just going to focus on the stuff that's new or important. So we have the wall, and the wall has, well to view, fine, but then view to projection, and that's the important part. So when we update it, first we get its view coordinates, and then we get its projection coordinates. Awesome. All right, so what are we doing? Well, first of all, remember we take the y coordinate of the view and we set that as the depth. Now, just remembering that because of Pygame's coordinate system, a y offset above the camera would be a negative number, and a y offset below the camera would be a positive number, but that doesn't quite make sense. So we just multiply the depth by -1. Great. And then we take, just to make sure we're never dividing by 0, we compare it to 0.01. And I just realized we actually don't need this line here because we're taking absolute value, so that'll always be positive no matter what. Okay, so what do? We take the x coordinate. Remember, the view coordinates are naturally centered around the center of the screen, so we can just work with that, divided by its depth. Okay, for the top, we have the wall's z height, it's ground level, plus its height, and then minus the camera z. So I think the wall is set at a level of 0, height of 80, and then the camera is a height of 30. So the top of the wall should be 50 pixels above the camera's view. Then we just apply a negative because of Pygame's coordinate system and divide by its depth, just like we did with the x offset, then do the same thing with the bottom. Okay, and then we go through exactly the same calculations with point B. So we have depth and all of that. Okay, now we use this information to construct a set of points, so 4 points running from point A to point B, you know, with top and bottom. Pause the video, have a look at this. This makes a rectangle, quadrilateral. Okay, so it just turns out as a consequence of this that these go into what's called normalized device coordinates. So it's stuck somewhere between -1 and 1 for X and Y. Now with OpenGL, it's kind of the opposite on the Y. So with OpenGL, +1 would be the top, -1 would be the bottom, but the same kind of idea applies. In order to graph it, we need to stretch all the points back up to the size of the screen and then add on the center of the screen, so move it, you know, to the center of the view. So great, no problem. We just loop through that. Now, just having a really quick look at this. This is fine. No, that's fine. That's all right. Okay, so yeah, what do? We stretch it back up to match the you know, width and height of the screen. We move it to the center of the screen, and then we just draw it. So if I run this, you know, it looks okay, but not quite, right? So just so this makes sense, we'll move outside, and now it looks good. Okay, awesome. So then we walk towards that corner with the green and the purple, and we get closer and closer until it seems to bend with us. And why is this? Well, the reason is the program is trying to draw the wall which is behind us, but we haven't really coded that in. So it just attempts to draw the wall behind us. It gets the distance from the camera because we used absolute value, and that's how it gets on the screen. It's kind of drawing everything at the same time, which isn't great. So what we need to do is a bit of clipping. Okay, no problem. That gets us to the next version. As usual, all of these files will be linked in the description. Okay, so when we go view to projection, we take our data, and the first test we can do, right? So remember, just checking. Okay, so remember with Pygame system, a positive Y value will be, you know, behind the camera or below the camera. So if both points have depth behind the camera, it's safe to assume that the whole wall is behind the camera, and just return. In other words, don't draw anything. By the way, these little lines here, after Python 3.9 came in, they started doing little suggestions like fix your code. And it's complaining that it's not, you know, all the way. Like this is probably saying there's no docstring or something for the method. Little helpful hints. Okay, so where was I? So one case is where both points of the wall are behind the camera, in which case, okay, just don't draw anything. Another case is where one point of the wall is behind the camera. So here's how I kind of fix that. If we look at the view coordinates, there's a horizontal white line, and this represents the near plane of the camera. So if we look at the yellow wall is partly in front of the camera and partly behind the camera. So what we need is, if we imagine this near plane extending in both directions, we need to find the intersection point between this yellow wall and the near plane. Wherever that point is, take that. If this is point A, make this the new point B. And this code is completely symmetric. So if this is point B, this will be the new point A, no problem. And just draw the wall based on that. So the method that we use to find the intersection point is done in this function called clipLine. And there we have it here, a bit of math. So what I did is actually just looked up Wikipedia article, intersection between two line segments, and it gives us this formula. And I just made these simplifications here. So this num A, num B is two different numerator expressions which were showing up in the code. Just look up the Wikipedia article and compare. But this is just a quick way to get intersection between 2 points, 2 line segments. Okay, so, I mean, not much else to say. That's about it. Otherwise, the code is exactly the same. So find the intersection point with the near plane and set that. So if it's point A, which is behind the camera, then clip point A. Otherwise, if it's point B, then clip point B. Okay. And then just run the same code that we ran before. Only difference is at the start here. At the start here, I took the Y values originally from Pygame system. And then when I go to draw them, I want to draw everything, in front of the camera, so everything with a negative depth. So I just flip it by -1. Okay, great. Yeah, otherwise, that's it for now. Code is in the description. And that's it. Have fun.